Hello. In this third part of this implementation of IoT with Raspberry Pi, we'll be covering the topics we discussed in the previous two lectures, that is integration of sensor with your Raspberry Pi. Then in the previous lecture, that was integration of sensor with the Raspberry Pi and making the Raspberry Pi, configuring the Raspberry Pi as a client device, and we configure another desktop PC as a server device, and we initiate communication between this client and server, and we also initiate storage of data when the data is being uploaded onto the server. And thirdly, in this part we'll be focusing, besides those previous applications, we'll be focusing more on the server side, that is, once the data has arrived, what exactly can be done with the data. So as we have covered previously, we are mainly focusing on creating an interactive environment using a network of connected devices, and the data logging being done is remote, which is connected to a network, and the data may be processed on the client side as well as it may be processed on the server side itself. Again, going through the system overview, as you can see, we'll first start off with a network of temperature and humidity sensors connected with a Raspberry Pi board. For this demonstration, we have connected only one sensor to a single Raspberry Pi. We read data from that sensor, we send it to a remote server over the network, we save the data at the server. Then till this part we covered in our previous lectures. Over here we'll be doing all these things, and after that we'll be splitting the data which we saved in the data logs, and we'll try to create a running plot of the data which is coming into the server. So imagine, regarding this running plot, imagine your devices, you have a network of devices spread over a city and which are uploading data to a remote server, and instead of running the script on a local server, if this can be hosted on the internet, you will be able to access your sensor readings, sensor data. You may be able to remotely actuate your sensor or actuators or IoT node from any part of the world, and you may be able to visualize the changes in the environment in a particular area to which the node is deployed by accessing the whole system through the internet or through a browser. So again, back to this topic. For this remote data logging, we'll be using the DHT sensor and a Raspberry Pi. The pin configuration: pin 1 is connected to power, pin 4 to ground, and pin 2 is connected to the data pin. The Raspberry Pi interface is the same as before. Only change is pin 2 of DHT is connected to pin 11 of the Raspberry Pi. So we already have the Adafruit Python library for this DHT sensor, and we have all the libraries installed as covered in the previous lectures. The code is also similar to the previous lectures. So on the left hand side, you can see this is a screenshot for that IoT-sr.py file, and on the right hand side you will be getting the output once this file is run on the Raspberry Pi. You must remember, this IoT-sr.py file is kept on the Raspberry Pi, and when you remotely run this file, it will generate a temperature and humidity value. So this will be on the client device itself. Sorry, this will be on the sensor device itself, which is the Raspberry Pi. We cannot call it a client yet because it has not been connected to the network as of now. Now when we attempt to connect this over the network, we create a client server architecture and establish connection between one client device and a desktop which acts as the server device. And once the data transmission from the client initiates, successive data will be incoming into the server and get stored into a log file. Now, till the previous slide, we had covered all these things in details in lecture 2. So over here, we'll be going through those as well as basics of data processing like data splitting and filtering and data plotting. But big question is, why do you need processing of the data? As in, imagine you have hundreds and hundreds of sensors all rapidly uploading their data to this remote server. So at certain instances, there may be chances of data corruption, there may be chances of incomplete data being transmitted, there may be chances of server not able to receive the whole data despite the client sending the whole data. So there may be various reasons. The data may not be properly formatted and so on. So in those cases, you need to filter the data to create a seamless and well structured database. And as regards to data splitting, since you have multiple data coming in from a client, which may be stored in the form of a CSV file or even in the form of a text file. So we need to, if we need to access individual data, suppose you're getting temperature readings, humidity, maybe presence of gases, light intensity and so on. So suppose you have 5 to 6 sensors connected to a single node, and these data are routinely updated to a server, but you only need to access the temperature value. For this to happen, you need to split your data at the data log. And once this data has been split and individual data can be accessed, we can go about plotting this data. Regarding this data splitting, now imagine the data from the client is saved into a text file and the values are separated by a comma. As we have covered in previous lectures, this is called a CSV or comma separated value file. So instead of a comma, you can use any other delimiter. It may be a semicolon, it may be colon, it may be even a question mark. Better avoided, but still. So these values which were incoming, it were in the form of string h, comma, string t. So we need to split these values on the server in the form of individual h and t's. So we'll be using this basic inbuilt function of Python called split. So it can be used to split a string into multiple strings depending on the separator or the delimiter we are specifying. For example, suppose we take a data string as, within single quotes, we assign Sunday, Monday, Tuesday, or it can be any other data string separated by a delimiter. Over here the delimiter is this comma, we have chosen this as a comma. Now when we call this data.split function and we specify the delimiter in the arguments, you'll see the result will be individual substrings Sunday, Monday, Tuesday. We input the data as a single string Sunday, Monday, Tuesday, but we get the output as individual data strings. So it would be better if we just do a bit of hands-on. So let us suppose our data is maybe 1, 2, 3, ABC, right? So I have given 1, 2, 3 numeric value, I have given ABC alphabetical value, and I have given a combination of both alphabets and numbers. So this is my data. Let's check what has been stored. So this has been stored, this data variable has been assigned a single string, that is 123, ABC, XYZ12. Now I need to split this data. So I use data dot split. The separator I have used is a comma. You see, it has been split into 3 different parts, 1, 2, 3, ABC and XYZ12. You must remember, since these were separated by comma, so these have been separated accordingly. You can obviously go for another value. let us say data equal to 1 2 3 4 3 2 4 5 4 A B C 4. So I have used too many 4s. Let us see what happens. So this is my data, right? Now I'll use the number 4 as my delimiter. So data dot split. I'll give the delimiter as 4. You see? So according to the position of 4 in the string, your single string has been broken down into multiple substrings, and the 4 delimiter is obviously not included. So you have 1 2 3, then you have 3 2, then you have 5, then ABC, then a blank since it has 2 4s, so it includes a blank, and then RT, right? So it's quite simple. Now regarding data plotting in MATLAB, so regarding data plotting in Python, it is quite similar to plotting the data in MATLAB. So both of these support a very powerful library called matplotlib. So this matplotlib library, you can use the appropriate version in MATLAB as well as in Python. Most of the functions are almost same with a bit of variations, but it's more or less same in both the languages. So basic commands for plotting in 2 dimension are, you write plot x comma y, where you put the x-axis and the y-axis values. X label gives provides the labels on the plot for the x-axis. Y label provides the label on the plot for the y-axis. Title gives title to the whole plot. So this is a sample code. Import matplotlib.pyplot as maybe a variable, and then you call this myplot.plot. You give a range of values, then myplot.ylabel, you name it y-axis, and you show this plot. So we can again go for a bit of hands-on. Let us say we import this matplotlib function as, let us say, plt. We define a variable as maybe I'll give a range of values, maybe from 1 to 20. plt.plot, I put in a, plt dot show. So when I run this basic code, see what I have done is I've imported this matplotlib.pyplot library. I've defined a variable a by assigning a range of values between 1 and 20. So this range function automatically assigns values. Let's see what it does. Range 1 comma 20. So it will give you a range of values between 1 to 20. Now we initialize this plotting by calling a figure. Within this figure we plot this value of a, which will be obviously corresponding to the y-axis. The x-axis is, if not provided, it is automatically taken, and the show function shows the plot. So once we run this thing, as you can see, this plot has been generated. since it is a linearly increasing line 1 2 3 4 up to 19, so it will give you a straight line. You can even change the plot type. Let us say instead of plt.plot, a straight line plot, let's go for a scatter plot. Sorry. Better still, it will be more interesting if we give two values. Assign a variable a1 as for this we have to import this random function. If you remember, in one of the previous lectures this random function was also covered. We need to import the random function first. Sorry, starting and ending. So whenever you are in doubt, for this particular spider-based console, you can actually check in the syntax of this function, or you need two arguments a and b. Let's say I give a as 1, b as 20, and put this whole thing within range. So this will be my range. I'll start with this. I'll change this to length of a1, so it is denoted by len a1. When I run these two together, so a1 is 0 to 5, a is 6, right? Sorry, this is going to be only scatter. So there seems to be a size mismatch. So for this scatter plot, we take two arguments, one for x, another for y, and we have used two functions. For the x1, we need a linear spacing of numbers, so we have started off with -1 because this won't be included. It will go up to 50 with a step size of 1. So you'll have 0, 1, 2, 3, 4, 5, 6 up to 50. So you have 50 points on the x-axis, whereas we call a random function from NumPy library module. Let's call it import NumPy as np. So from this NumPy module, we won't be requiring this. So np.random number within arguments 50 means it will generate 50 random points. So this will act as my y-axis or the data points. So corresponding to the points on the x-axis will have corresponding randomly generated points on the y-axis, and within this same figure and show. Let's see what happens when we run this thing. So you see on the x-axis and corresponding to the x-axis you have 50 points on the y-axis. So let's add a few bits to it. If you run this part, you've just added a title for this plot. You see this scatter plot example. Additionally, you can have plt.ylabel. You must remember these labels are strings, so should be within quotations. Let's put the y label as randomly generated, the x label as linearly spaced. Let's run this. You see the y label has changed to randomly generated, the x label has changed to linearly spaced. Just add one more command to it. If you add this command, it will turn up a grid on your plot. So you have a linear grid on your plot. So I hope this basic plotting function is clear. So you have a simple plotting, you have labeling, you show this plot, and besides your normal 2D plot, line plot and scatter plot, you have a huge range of plotting options. You can even venture into 3D plots, which are much more attractive in a browser based system or for various publications. So this basic plotting you saw previously. Now some other functions used in plotting. I've covered this figure, it creates a new figure. Grid, it enables or disables an axis grid on the plot. Ion is the interactive plot mode. This is generally used for animations. Your subplot, it adds a subplot in the figure. Close, it closes the current figure. And scatter makes a scatter point plot of the given points. So we'll try this small. So it would be better if we directly go into this model again. So if you remember, for the client side, this sensor data module is more or less same. In fact, it is the exact same one. The client doesn't require a IP address because we are aiming for a one-way communication from the client to the server. So we just put in the server's IP address and that required port on which the server is listening, and just like before, we are packaging the data in the form of H and T and transmitting it over the socket to the server. Now on the server side, we have added a new function called coverage plot. So what it does is it animatedly plots whatever data is incoming into the server over the socket. So for the time being, ignore this part, this particular function. Let's pay attention to this socket creation. So it is somewhat similar to the previous examples. Over here, your server address is the server address and the particular port to which the server is listening. And while it is true, it is receiving data in 4096 byte chunks You open a data log file, store the data to it, and additionally call this plotting function. So this plotting function is being called again and again, basically iteratively within this loop. So as long as your data is incoming, this plotting function will keep on going. So once the server is closed by the user or the client is closed by the user, this plotting function will stop. So, and this I+1, this keeps on incrementing this normal counter which we send to the coverage plot. Now coming back to the coverage plot, it accepts two arguments. One is the data which comes from the server, and I, which is the counter. Now the data is being split in terms of two parts, humidity and temperature. So after splitting, since the data was in a CSV format, so after splitting, the 0th element becomes humidity and the first element is temperature. So you need to actually study the data very carefully, like what format the client is sending the data and so on. Now if you want to print the temperature, you just print the temperature and the iteration number. Then you start the interactive plot mode. You set the figure to a similar number as in number 1. Otherwise it will keep on creating new windows every time it plots something new. You set the window size to 6,6, it can be 8,8. It's up to the user actually. You give the plot a title, you add a subplot to it, and just basic, you plot the temperature versus the iteration, that is normal temperature plot with respect to whatever data is incoming. You label it. Similarly, for the humidity part also, you iteratively plot the data against I, and eventually show the data, and figure.canvas.draw, it redraws the image without overwriting the previous points. So your output will be something like this. So this will be on the Raspberry Pi. This is the client code, and on the server side you will be getting your data as you have covered in the last lecture, and for the plot you will be getting something like this. The left one side is the temperature plot, the right one side is the humidity plot. So let's look at the plots. First of all, I'll start my server. So this desktop I'm operating acts as my server. So I'll open up my server. So my server code is now running. Now I log into the remote client and I need to run the client code, which is the same as the previous one. So one more point you need to notice is, suppose you have 100 clients, you do not need to update each and every client. Even if you need some minor adjustments, make some minor adjustments. So you can just update a singular source code or a singular script file on the server end, and that will save you a lot of time as well as a lot of effort. So I'll run this client code. Client.py. So you see, client has started sending the data, and on the server side it is receiving the data. This is a new addition, this iteration number. So this keeps on increasing. The left hand side denotes the temperature on the plot. The right hand side denotes the humidity. So maybe we will stop the plot, run this thing again. So see, even after stopping this program, data which was previously stored maintains there. So there is very minute variation between 75.5 and 76, so it is giving changes, whereas the temperature is more or less constant. So we'll try increasing the temperature a little bit. And you can see the plot changing. As you can see, the temperature points now logged are rising. See, the temperature has risen. And there have been changes in the humidity also. Now let's wait for it to recover. Now you can again notice the temperatures gradually coming down. On the left plot, the red plot, you can see the temperature gradually coming down in steps. So this will keep on coming down until it reaches the normal room temperature value. So now let's close the client program. See, the client program has been stopped manually, and this data logging stops. So one more thing you notice is, in the previous examples, your temperature, humidity values were coming in concurrently. Now in this one, since we have splitted the data over here in these parts, so we have a separate temperature component, an iteration number, and a separate humidity component. Which is saved in the same data log. Data log is still the same, only the scripting part has changed. So this thing will help save you a lot of effort. You don't need to individually code the clients. So once your client has been coded and deployed on the field, if you need to make changes, design your architecture in such a way that only changing the server will help you, only changing the scripts on the server will help you change your whole implementation and functionality. So I hope this was of some value to you. Thank you.